Hi, I'm Rich with Inside HPC. We're here at ISC 2015 in Frankfurt, Germany, and we're here at the CoolIT Systems booth. And I'm here with Patrick McGinn. How are you doing, sir?
Doing good. Thanks, Rich.
Well, good. Thanks for having us.
You bet.
You know, I think we should start at the beginning, Patrick.
Sure.
I mean, who is CoolIT Systems and who do you help?
So CoolIT sells solutions, warm water liquid cooling solutions to the HPC and other data center markets. HPC being one of our biggest segments that we sell into.
Okay. So what do we got here? We got to see a lot of components.
Yeah, you bet. So CoolIT offers a modular approach to liquid cooling. So we have three major modules that we sell. The first is a server module that goes inside the server. Then there's the heat exchanger module and the manifold module. So we'll walk through each of those three today. We'll start right here. So the server module is comprised of a few key components. Number one is the cold plate, which is a big part of CoolIT's intellectual property. We generally sell passive cold plates with a centralized pumping system into the data center market. So you have the cold plate, you have any different size of tubing that we need to negotiate our way through the server, and then of course it terminates in a dry break quick disconnect. We use Stobly metal quick disconnects. We think that metal is very important for reliability and that it's a data center grade product. We also do memory cooling in some instances. So we have several different styles of memory cooling that we sell into different server product depending on the size and type of it. And we also do some customized components if required for other culprits like VR or chipset or something like that.
Okay, can we take a look at how this might look together in a module and how it all cools the system?
You bet. Come on over here.
All right, Patrick, what are we looking at here?
So what we're looking at is the newest addition to CoolIT's cold plate family. So a lot of the same server module components, but instead of our standard R4 cold plate, this is the Intel Phi coprocessor Knights Landing cold plate. So it'll manage that chip. So something that we've developed with Intel's help and that we're eager to showcase this week.
Yeah. So the Knights Landing has something like 72 cores. It must generate a lot of heat. And you guys are able to take that away through the liquid cooling.
That's exactly it. Yeah, a massive amount of heat off this system. We're commonly asked to work on the VR as well with this system.
Okay. Do you have a more conventional kind of Xeon thing going on here as well?
Do.
Yeah.
Here's a good example of a recent installation we did at the Poznan Supercomputing and Network Center in Poland. So not only did we manage the Xeon E5 processors, but also all of the memory DIMMs inside this server. So in this instance, we captured 80% plus of the total energy power into warm water.
Okay. So you talked about the warm water. What happens when it comes out of here? How do you deal with that?
That's right. So the next thing it hits is our next module, the manifold module. So I'll take you over there and show you that.
Okay. So Patrick, here we are at the back of the rack. What happens with the flow of the liquid when it comes out of the modules?
Sure. So the next place the warm water will hit is the manifold module. So a typical manifold module for us is 42U, but we do customize it often for different customers. Here we're seeing it at the back of the rack, where other times we'll see it at the front of the rack using the front I/O style servers. So how it works is each server has two dry break quick disconnects, one supplying warm fluid to the server and the other taking the now even warmer hot fluid back to the manifold. Once we have all the servers aggregated in the manifold, we can take it either directly to a heat exchanger or up to plumbing, and then a row of racks will reach out to a heat exchanger.
So Patrick, here we are on top of the machine, and this is one of your heat exchangers. How does it work?
Sure. So first off, we have several different styles of heat exchangers. The first type is our CHX line of product, which uses a liquid-to-liquid heat exchanger to capture all of the load delivered to it by the manifold and then exhausted by liquid out of the data center. The other type is an AHX, which uses fans on a coil, and it dumps that heat back into the data center room. It's kind of, you get maybe not all the efficiency, but get the horsepower. It's sort of the race car version.
Sounds like kind of like a radiator, right? It's you take the liquid takes the heat away from the engine, and then a fan blows over the radiator.
That's it. So we use that more often in a test site, sort of in a beta test.
Yeah. Our
most popular product is this, the CHX40, one of our liquid-to-liquid machines. And once you get all of that warm water to the manifold, it connects to the CHX40 with the same style quick connects, they're dripless quick connects.
Yeah.
And then we exhaust that heat through a liquid-to-liquid heat exchanger using facility water. We have a bunch of functionality inside this system. redundant pumping. We do dew point calculations to make sure there's no condensation. Full reporting on temperatures, flow, pressure drop, you name it.
Now, for facility water, could that be a closed system so that you're not, using up that resource, like going into some pool or something?
Absolutely. It depends on the IT environment. So oftentimes you'll see a closed loop to a dry cooler or a cooling tower and back to our system. That's right.
So this is almost like a 2U kind of setup. Do you have a bigger version of this?
Yeah, you bet. Yeah, so this is a standard 19-inch 2U rack mount system. We also have a CHX 650, which manages 650 kilowatts using warm water.
That's a lot of kilowatts.
It
That's
is.
a lot of server. Can we take a look at that?
Yeah, you bet. Let's go over here.
Okay. So Patrick, here we have the large scale heat exchanger. How does this work?
So this works similar to the 2U CHX40. Of course, being the CHX 650, it manages 650 kilowatts of power.
Okay, so put that in perspective. How many racks or nodes is that? That's
Sure.
a lot.
Depends on the IT, but that's roughly about 700 nodes being managed by one heat exchanger.
Very nice. And the same principles involved with the building facility water and pulling it away like that?
The exact same principles at play, and much of the same functionality in this system than our other CHX40. In this system, because it's not moved as easily, it has more service capabilities in terms of being maintained on the space it exists at.
So like an entire data center could run off this for somebody, couldn't it?
Depending how big your cluster is and how big your data center is, yeah, absolutely.
So Patrick, I guess we should step back. I want to ask you about the state of liquid cooling, because we've been talking to CoolIT Systems for a number of years. What's the latest? What's going on?
Yeah, you bet. I mean, there's a lot of activity. There's a lot of different people showing liquid. There's a lot of reputable vendors here at the show, I think. From our perspective, we now have over 30 unique installs around the world. And we're gaining momentum. So lots of different reasons people are using liquid cooling, whether it be a densification of their data center, looking for efficiencies. But we have multiple different solutions that we can deploy to usually help somebody out.